Here are the answers for the section 5-5 homework. Starting on page 172, we're asked to simplify, and we have an adding and subtracting fractions question. The technique is to make sure you have the same denominator, and then to combine the numerators, putting that answer over the common denominator. So all of the denominators are 5, so we combine the numerators, 3 minus 7 plus 11, putting that result over the denominator of 5. 3 subtract 7 is -4, and -4 plus 11 makes 7. The answer is 7/5. Certainly this step here can be done in your head, going directly to the answer 7/5. Number 3, we have a similar question. 5 over 4 minus 7 over 6 plus 4 over 1. Any whole number can be given a denominator of 1 to help you visualize it as a ratio. We cannot add or subtract these without a common denominator. Let's find the lowest common denominator. It is the LCM of these three denominators, the least common multiple of 4 and 6 and 1. That number is 12, because 4 can be changed into 12 by timesing it by 3. You're also going to need to times the top by 3. 6 can be changed into 12 by timesing by 2, and you need to times the top by 2. 1 can be changed into 12 by timesing by 12, and in the top times by 12. Let's rewrite this problem where all the fractions have a 12 in the bottom. This is 15 over 12 minus 14 over 12 plus 48 over 12. This is equivalent to the original problem. All of these fractions are identical to the ones that we had before. We've just changed the denominator to 12. Now that we have a common denominator, we combine the numerators together and write that on top of the common denominator. 15 minus 14 is 1, and 1 plus 48 is 49. 49/12. Number 5, we have another subtracting fractions problem. Notice that the denominators are already the same. So we combine the numerators and write it over the denominator. This reduces because top and bottom match perfectly. They cancel away and make the whole number 1. Anything divided by itself is equal to 1. Number 7, we have to add fractions, but we don't have the same denominators. We need to find the lowest common denominator. We need the LCM of 3a and 12a. That would be 12a. We can change 3a into 12a by timesing it by 4, and times the top by 4 as well. So this becomes 8 over 12a plus 7 over 12a. Combine the numerators together and use the denominator 12a. This makes 15 over 12a. This reduces because top and bottom both divide by 3. So this makes 5 over 4a. In number 9, we don't have the same denominator. You have to have a common denominator in order to subtract fractions. So what is the LCM of a 3 and a 2? It would be a 6. And what's the LCM of an x and an x squared? It's x squared. So we can make this be 6x squared if we times it by 2x, and times the top by 2x. We can make this be 6x squared if we times by 3, and times the top by 3. We now have 14x over 6x squared minus 6 over 6x squared. Combine the numerators together and put it over the common denominator. This is reducible because 14, 6, and 6 are all even numbers and will divide by 2. Let's divide all terms by 2. We have 7x minus 3 all over 3x squared. Number 11, we don't have common denominators. What's the LCM of 3, 2, and 12? It's 12. Notice that some of them have an n in it, but this one doesn't. our common denominator also needs to have an n. So our common denominator will be 12n. We can turn this into 12n by timesing by 4, and in the top. We can change this into 12n by timesing by 6, and in the top. We can turn this into 12n by timesing by n, and in the top. We now have 32m over 12n minus 6m over 12n plus 1n over 12n. Now combine the numerators together. 32m minus 6m is 26m. And then we're also adding n. And that's all over our common denominator of 12n. Number 25, we do not have the same denominators. Our lowest common denominator has to have this factor in it and this factor. So our LCD is going to be x minus 1 times x plus 1. We can make this have that LCD if we times it by x plus 1, and in the top. We can make this have the LCD if we times it by x minus 1, and in the top. 2 times x plus 1 makes 2x plus 2. And now we're adding. 2 times x minus 1 makes 2x minus 2. And that's all over our common denominator. Let's do some combining like terms in the top. 2x plus 2x is 4x. Positive 2 and negative 2 cancels away. So we have 4x on top, all over our common denominator. Number 27. Before we look for a common denominator, let's factor these binomials. So we're going to rewrite the question. It will become r minus s over 3 times r plus 2s. And this one over here is r minus 2s over 4 times r plus 2s. Now that we have factored form in the denominator, it's easier to see our lowest common denominator. This is a 3 and this is a 4. The LCM of 3 and 4 is the number 12. Notice that they both have the r plus 2s. So to make this into 12 r plus 2s, we need to times by 4, top and bottom. To make this turn into 12 r plus 2s, we need to times by 3, top and bottom. So 4 times r minus s makes 4r minus 4s. Now we have a minus sign. Let's put that minus sign with the 3 and think of it as negative 3. Negative 3 times r minus 2s makes negative 3r plus 6s. And that's all over our common denominator of 12 r plus 2s. Now let's combine like terms in the top. 4r subtract 3r makes r, and negative 4s plus 6s makes plus 2s. And in the bottom we have our 12 times r plus 2s. Does this reduce? There's an r plus 2s top and bottom. They cancel away, leaving the whole number of 1. So final answer is 1 over 12. Right here in the middle is something you need to be careful of. You've got to pay attention to if this is a minus sign or a plus sign, because that affects this number here that you're distributing in the parentheses. Number 31, let's factor the denominators here. So we have t plus 4 over 2t times t minus 1 minus, and then over here the denominator factors as well as 2 times t minus 1. Now let's make our lowest common denominator. They both have a 2, so we don't need to change the numerical coefficient. They both have a t minus 1, so that's okay, but this one has a t and this one doesn't. We need to multiply top and bottom by t. So this will become t plus 4 minus 5t, all over our common denominator of 2t times t minus 1. As I said last time, be very careful with this minus sign. When we're timesing the t over to the 5, you got to remember there's a negative in front of that t. Think of it as negative t times 5. Now combine like terms. 1t minus 5t is negative 4t, and then the plus 4. And that's all over our denominator. Let's factor the top to see if it will create a common factor that can reduce away. It starts with a negative sign, so let's factor out a negative 4, leaving t minus 1. That's all over our denominator. Notice the t minus 1's cancel away. Also, negative 4 divided by 2 can reduce. So the final answer is negative 2 all over t. For the review assignment, we're not doing adding and subtracting fractions. We're going to do multiply and divide. Before you multiply the tops together and the bottoms together, look for any reducing. 3 divides into 3 once and into 6 twice. X squared cancels x squared. It looks like we have 8 times 2 makes 16 on the top and just a 1 on the bottom. So the answer is 16. Number 6 is a dividing question. The first thing you do is write it as a timesing problem. Keep the first fraction. Now change to times. Do the reciprocal of the second fraction. Before you times the tops and the bottoms, try to reduce stuff. The 5 cancels the 5, just leaving a 1. 3 and 6 both divide by 3. 6 divides by 3, leaving 2, and 3 divides by 3, leaving 1. Can you cancel any m's? There's more m's in the top, so when you reduce them, the leftover m's will be in the top. This single m cancels one of those away, making a new exponent of 1. It looks like in the top we have an m, and in the bottom there's a 2. Number 8 is another dividing problem. So the first thing you do is rewrite it as a multiply question. Change to times, flip over the second fraction. Now look for reducing. X plus 1 cancels x plus 1, just making 1. And 3 over 6 reduces. 6 divides by 3 twice, and 3 divides by 3 once. In the top, we have 1, and in the bottom, a 2. Page 166. This time we have a compacted fraction, but we're still going to reduce it. So let's start with the numbers out front, 8 and 6. They both divide by 2. 8 divides by 2 4 times, and 6 divides by 2 3 times. Now the letter A. These two cancel 2 of these away, leaving an exponent of 4. Now the letter B. These two cancel 2 of those away, leaving an exponent of 1. In the top we have 4, a to the 4th, b to the 1, and in the bottom we have negative 3. You could leave the answer like this, or you could write it with the negatives out in front of everything. And then you have 4 a to the 4th b all over 3. Either of these is fine. Number 6, the part with the negative exponent makes a reciprocal. Let's rewrite this and put the thing with the negative exponent down in the bottom. When you move it, it now has a positive 1 exponent. Now we can reduce this. 6x divided by 3 is 2x, and 15 divided by 3 makes a 5. Number 10, what's on top is the exact opposite thing of what's on the bottom. The final answer is negative 1. If you don't see that right away, you can use factoring to do this problem. Keep the top the same for now, but then in the bottom, rewrite the order of the terms so that the variable term comes first, then the constant term. Keep the top the same, and then in the bottom, factor in -1 out the front. And that leaves y squared minus 4. At this point, hopefully you recognize that these cross out, making a 1. And so the answer is -1. Number 16, let's factor the numerator. There's a GCF of c squared, and that leaves 1 minus c. In the denominator, this is a difference of squares, and it factors as c plus 1 times c minus 1. Now, what did we just say in the last problem about 1 minus c and c minus 1? Two factors that are inverses of each other. When you cancel them, you're left with -1. So in the top we have -1 c squared, and in the bottom we have c plus 1. You might write this as just negative c squared all over c plus 1. Page 164, let's rewrite this as a rational expression. That is, as a ratio, one number on top of the other. Leave the 12t in the top, and then the thing with the negative exponent, move it into the bottom. Now it has a positive 1 exponent, but you don't need to write exponents when they're only a 1. Now it says determine any restricted values. Is there a variable in the denominator? Yes, there is right there. Is there any number that t cannot equal because it's in the denominator? Well, let's investigate this a little bit. Whatever number t is, when you square it, you're guaranteed to get either 0 or a positive number. So when you add 1 to it, you're going to get a positive number. T can be anything, and it's not going to create a 0 in the denominator. There are no restricted values. Number 24, let's rewrite this one and change the order of the terms in the bottom. The negative 2b cubed should go first. It has the highest degree. Then the negative 6b squared. And then the positive 20b. Now let's factor the denominator. It starts with a negative, so we're going to factor a negative in our GCF. And 2, 6, and 20 all divide by 2. So there's a 2 in the GCF. And there's a letter B in all of them. So there's a B in the GCF. That's going to leave a trinomial. Negative 2b times b squared is the negative 2b cubed. Negative 2b times positive 3b is the negative 6b squared. And negative 2b times minus 10 is the positive 20b. Does this trinomial factor farther? Let's try. So we have our b minus 1 on top, and in the bottom the negative 2b, and then let's use FOIL to factor that trinomial farther. b times b, then two numbers that times to negative 10, and they add to positive 3. How about positive 5 times negative 2? Does anything reduce top and bottom? No, it doesn't. So here's our answer, but we're asked to give restricted values. And this is another reason why factoring is helpful. Look in the denominator and take every one of these factors and figure out what value you can't have for b. So let's start with this first one. The negative 2b, we don't want that to be 0. Divide by negative 2, both sides, and we find out b cannot be 0. Okay, or this next one, the b plus 5, we don't want that to equal 0. So subtract 5 from both sides, and we find out b cannot equal negative 5. Or this last one here, the b minus 2, we do not want that to be 0. So add 2 to both sides, and we find out that b cannot equal 2. We have 3 restricted values. You can't have 0, you can't have negative 5, and you can't have 2 for the letter b. Because if you did and you plugged them into this original problem, it would make the denominator turn out to be 0.